hand it to the center and I'll collect them. Do not despair about bad quiz grades. You know, the more I give, the better it works out for you, because there will be like extra points in the quiz grade. So it's possible to have an average of something like, I don't know, 80 and still have 100 points a quiz grade, something like that. So just do your best. Oh, an extra? All right. Thank you. Thank you.
This test out of 150 or 200?
200. Thank you. No, you guys get to. You guys always ask me this, if you get to keep your tests. The answer is yes. I make new tests every semester that I teach a course. The idea of reusing a test semester after semester, not letting students have back the test, that's just lazy. Uh-oh. All right, so let me begin with a word of prayer here, and then I'll talk about the solution to test 2. All right, so let me begin. Again. Today, Father, we thank you for this day. Thank you for the students. Just ask you just bless our work today, Lord. In your name I pray. Amen. I know you guys are just like all on edge because you know about the FLOTUS, and you know it's hard to think about anything else. You know the FLOTUS? The first lady of the United States, right? You guys don't know this? It wasn't the question. It was an invitation for snarkiness. Okay, so this one you pretty much couldn't get wrong. Even if you didn't circle a choice, I still gave you 10 points. So, all right, I mean, don't expect me to do that next time. The predominant choice was number 3, as it has less scary sounding things, I think, like nuclear particles. And the fluids is not too bad, but I definitely get to talk about relativity. And since a lot of people picked 1, I may still do something from 1. But anyway, all in good time. Although there's not much time left, is there? So let's get on with it. Problem 1, you have a 70 kilogram running back moving at 4 meters per second, collides with this other guy who's initially at rest. What's the resulting velocity of the football players? So this is just straight conserve momentum. Conservation of momentum, so the mass times velocity before, the total mass times the final velocity since they're stuck together afterwards. I do the math, I get 1 meter per second. And the answer is no, this is not an elastic, it's inelastic, and we can prove that by noticing that the kinetic energy before and after, well, before you have more, after you have less. If you actually calculated this, and said this correctly, I gave you 3 bonus points. Partly because I just don't want to take points off people who haven't done that, but have said said that it's inelastic or that it's not elastic on the basis of the fact that it was a sticky collision. Like that is an intuition that I want you to have. If things stick together, if they don't bounce off, then that's going to be a collision in which kinetic energy is lost. And so if you had that in mind, I wanted to give you full credit. But on the other hand, I wanted to give you more credit if you actually ran the numbers and showed me that kinetic energy was lost. So that's why I gave 3 bonus points for people who did that. Of course, physics is better with ninjas. So I added a ninja to this problem. And so here, I tell you the initial velocity, I tell you the mass, and I tell you a horizontal force of 100 newtons is applied. Now, I had in mind a horizontal force that went to the right. Some of you interpreted it as a horizontal force that went to the left. I still gave you full credit if you did it that way and did it logically. But the basic idea here is just that force is the change in the momentum over the change in time. And you have the force, and you have the time. So you can figure out the change in momentum. And since the only thing here you don't know is the final momentum, you can solve for it. and you get this. So now, this is a common theme throughout about half the test. Vectors are vectors. They're not numbers. So a vector is a pair of numbers, right? And so for this course, I've almost always written them like this. If you did something like just add these numbers together and give me 200 kilogram meters per second, so you'd be wrong. I don't think anybody did that on this problem. You guys don't do crazy stuff on this problem with the vectors. It's the later problems where the whole concept of a vector was called into question. We had things like number equals vector, or number divided by vector, as this is a thing. I mean, it got nuts. Like this next problem here. Oh, no. Wait a minute. Page down. So this is just like a problem I worked in class, right? I think I might have had 4 things in the one in class. I forget. Maybe it was even 3-dimensional. This one's 2-dimensional. So I give you the location of mass 1, mass 2, and I tell you mass 3 is placed there even. And I tell you where the center of mass is. The question was, what is the actual value of M3? So all you have to do is set up the center of mass vector, which is this. Plug in what you're given, which is all that, and solve for M3. And the thing is, to do that, you have to do, correct steps. So these add together to give a 5M3 minus 1 comma 4. I multiply that to the other side to get 3 plus M3, 3 plus M3 like that. And then this gives me 2 equations. It gives me 3 plus M3 is equal to 5M3 minus 1. And it also gives me 3 plus M3 is equal to 4. I prefer the y component to the x. The y component's a little bit easier to see, that if 3 plus M3 is 4, that means M3 must be 1. And so we get M3 is 1 kilogram. Now, lots of you have the right answer, and your work looks nothing like mine, and that's fine. Like the way I calculate is the way I calculate. The way you calculate might be different, but we should all agree on the answer. So, clues that you have a wrong answer. Mass. My mass is a vector. No, mass is not a vector. This is not allowed. If you find yourself writing mass equals to vector, you are in a bad place. Go away from that place and replace it with mass being equal to a number. Just make one up. It'll be better. Because whatever you've done to get to the point mass equals to vector, it's wrong. Go away from that place. Now, I'm talking to, and you might think I'm like picking on one person in here. No, no, no. I'm picking on like 40% of you. All right? So please look at the solutions to the test. So if I ask a similar question on the final, you're not like blindsided by it. I did do an example like this in class. I know when I do an example in class, it doesn't like automatically stick in your brain so you can do it again, but Problem 4 was a lot like an example we did in class. Not quite the same, but similar. And this is a work energy theorem problem because I tell you that it's initially at rest, and I tell you, I think, that it builds up to 2 meters per second. It happens over some distance. We don't know what that distance is. The question is asking, what is that distance? So I can use the work energy theorem, which says, and this is something some of you guys don't have clear yet. You're trying to do work energy, but you're assuming that like the force of the work energy theorem was just the friction force. That's not the case. Work energy has to be, it's tied to the work done by the net force. And the net force here is the pushing force minus the force of friction. So the net force is 27.5 newtons. So to get the work done by the net force, I do 27.5 times delta x. Now I don't know delta x, but I can figure it out. Because I also know that the change in kinetic energy is equal to the work done. That's the work energy theorem. And so I can calculate the change in kinetic energy is 50 joules. So 50 joules is equal to that, and I solve for delta x of about 1.818 meters. Next up, problem 5. I think a fair number of you actually got problem 5 correct. I was happy to see 48 point whatever degrees there. Maybe that's because I pretty much said this would be on the test, and you heard me, right? I don't know. This is a pretty standard question, although my diagram is new. I'm kind of proud of this. Although I'm less proud of, is this where I misspelled horizontally? Is that the one? Somewhere horizontally is missing a Y, I noticed. The thing I write these things in doesn't have a spell check or a grammar editor. Anyway, so you calculate the momentum of the police car before, the momentum of the ice cream truck before, which is just mass times velocity. Velocity is a vector. Have to think in vectors. Physics is about vectors in part. Two-dimensional physics demands the vector concept. We have to think in vectors. Momentum of conservation of momentum is a vector conservation, all right? So the momentum of the truck plus the momentum of the police car is going to be equal to the combined mass of 5,000 kilograms times the final velocity. And so I can solve for VF by dividing this by 1 over 5,000, which gives me that. Ow, man, we put that there. So I got 18 meters per second, comma 20 meters per second for my final velocity, and that indicates the direction in which the thing skids initially, right? And if you do the trigonometry here, we get inverse tangent of 20 over 18, which is 48.01, which a lot of you got. Problem 6 is pretty cut and dried. Here we're given the torque is 30 Newton meters. The wheel has radius 10 centimeters. And, okay, so it's a wheel, which means that the moment of inertia, oh, I told you the moment of inertia. That's kind of boring. 15 kilogram meters squared. So I do 30 divided by 15 to give me my alpha, because alpha is torque over I, 2 radians per second. Now, this problem, I forgot to put something important here, which was what? That the initial angular velocity was what? Was 0. But this was announced in class, remember? So this is 0, and we have 1/2 alpha t squared, which gives us 100 radians. Then you have to convert to revolutions by multiplying by 1 revolution for every 2 pi radians, and I get 15.92 revolutions, which a fair number of you got. Now, when you're reading a question on the final, if you have the feeling that something is missing, please contact me like immediately. It may be that there's like a different way of thinking about the problem than you're doing that I could like alert you to. It might just be that my problem just somehow forgot something, and despite my double checking on the final, it hasn't leapt off the page at me. So don't be afraid to ask if you think something's missing, all right? I don't mind you asking me about that on the final. Here, I ask you to find the torque due to a force on a bar about the origin. So the torque is R cross F, and that works out to 7 minus 8.3 Newton meters. I took the dot product of the torque with the radial arm. I got 0. I took the dot product of the torque with the force. I got 0. So as you can see, my cross product is correct. Many of you are not listening to my advice and checking your answer because you had something other than this and you didn't check it to see that it was wrong. But some of you have it. So, yay. Yep. Yeah, the final's cumulative. Indeedly doodly. It will cover tests 1 and 2 and the stuff I'm about to say about sound and waves and relativity and maybe a little bit of particle physics. So, but that material is partly less mathematical, so it leads to some kind of short answer stuff, which I'm sure you guys are like way better at than my typical students. My typical students seem to be pretty good with like equations, but if I ask them to write a sentence, they're like, ugh. Is this some sort of Gregorian chant? What's going on out there? I mean, it's okay. It'd be understandable outside. I mean, because we got the Got the music going out there, right? Why don't we have music in the hallways too? Let's get nuts. Let's have music everywhere. What do you think? Why don't we have elevator music? Shouldn't we be able to watch something in the elevator? Should have like the Liberty Channel going, right? I don't know. I mean, the glass elevator's got a show, but anyway, so the torque, the magnitude of the torque is 11.05. A lot of you guys got this, great. And then the angular acceleration would be the torque divided by the moment of inertia. And I was fine if you wrote this as a vector. Like you could say it's a vector, that would be okay. But I was also fine if you did the, calculate the magnitude, define the magnitude of the angular acceleration. And a lot of you did have the correct I here, and I was very happy to see that. Even if you messed up part A lot of you at least still had the 1/3 ml squared here, so you picked up on that. That was good. Now some of you put like just ml squared and didn't have the third there, so you got something to think about. Not a big deal, but something to think about. It's because we're rotating around the end point of the rod. The moment of inertia is 1/3 ml squared. And that gives us 0.3682 radians per second squared. Now, this one, again, I left out a crucial piece of information in the interest of us having a numerical answer rather than a family of answers, which is that the length of the pendulum I gave you is 40 centimeters, like, in the middle of the test, I told you guys this. And so a lot of you have tried to solve this problem by just copying off your formula sheet, the thing we derived for the ballistic pendulum, but this is not the same ballistic pendulum. So you can't just use the canned formula without thinking. Us physics people, we tend to do this. We really are more interested in you understanding conservation of momentum and conservation of energy than I am you just plugging things into a formula, right? When I think just plugging things into a formula, that to me feels more like physics 101. This is physics 201. There is some analysis expected in here, all right? So you want to understand the nuts and bolts, and here it's a two-step thing. So we conserve momentum in the process of the bullet passing through the pendulum. That gives me an initial velocity of 0.5 meters per second on the upswing, and then we conserve energy on the upswing. So otherwise it's pretty much the same song and dance as the regular pendulum, but and that gave me 0.0126 meters for h when I calculated it. And so then I still have to figure the angle out, right? And so since there was 0.1276 meters, that means that there was 38.72 centimeters over here. And so then I can figure out that angle by taking the inverse cosine of the ratio of the adjacent to the hypotenuse, which I got to be 14.53. It is possible I've made a miscalculation here. If you double check your work, and you actually got a different angle than mine, or if you find a mistake in this one, I'd like to know about it. It's possible, because I don't think a lot of people got this, and I feel like more people should have got this. It makes me think maybe there's a mistake in this one. I'm hoping that I have a mistake, so you can show me that you got it right. But I can't be sure about that at the moment. Round-off error is a big deal in this one. If you're careless about these digits, it could make a pretty big difference in the angle. Anyway, I'm going to go on. Problem 9, we had a uniform sphere. I reminded you that the moment of inertia is 2/5 mr squared, and I said that it's given an initial push of speed 10 meters per second, and then what's the, wait, I can't read my own problem. Oh yeah, initial push with 10 meters per second, and it rolls without slipping. How high up the plane does it go, right? What's h? Isn't that what I say? Did I say find h or find x? I can't remember. Oh, find x, yeah. Because we found h in class, so I figured if I asked you to find x, that would test whether you understood it or were just copying the formula from class. Sorry. So we test for understanding sometimes. You know, it's annoying. But it is our custom. So the idea here is simply this. The initial kinetic and kinetic energy, rotational and translational, gets converted all into potential energy at the top of the motion, right? So I just set the sum of the kinetic energy is equal to the potential energy at the end using conservation of energy. But the thing is, the rotational is 1/2 I omega squared, whereas the translational is 1/2 mv squared. But when you actually put in what I is, you end up just getting that these two terms combine, because remember, omega, r times omega is v. That's the rolling without slipping condition. And so I'm able to do that. We can actually, it didn't matter that I didn't tell you exactly what the mass was. They cancel out. And you can solve for h. You can solve for h here. What do we get? H is equal to 7v squared over 10g, which I worked out to 7.143 meters. Here's a picture. There's the x I'm after. Here's the h that I calculated from conservation of energy. Could we engineer a louder trash can? What do you think? Like, could you solve the louder trash can problem? Like, make a louder trash can. How could we do that? I don't know. Sorry, I'm easily distracted, as you know, by now. Tangent of 20 is 7.143 over x, and so I solve for x. I get this, I get that, 19.62 meters. Now, many of you did not get 19.62 meters on this problem, and yet I did not take off points. How did that happen? I was tired of taking off points at this point in the test, so if you had some semblance of work, I didn't take off points. Now, it's still possible to lose points on that. If you really did something that was so identifiably horrible, I just couldn't look away, I took off points still. But some of you have done very, very silly things there and have not lost points. My apologies to those, both of two classes of people. One, the class of people who were not silly enough and still got points taken off. And two, the people who actually got 19.62, and I have not distinguished from the rest of the crowd. My apologies. I will try to do better and take off all the points on my next grading. Okay? Okay. Now, similar comments apply to this one, which I thought would be fun to bring back again in a slightly different fashion. See, that's the actual answer. Many of you, a lot of you had that. A lot of you got this. And some of you didn't. But I really like this problem because on test 1, I asked the same thing was on test 1, right? But what question did I ask there? What question did I ask? I think I asked what theta was, didn't I? Yeah, in question 1, test 1, I asked what was theta, if I recall correctly. And that's a hard question, all right? And I knew it was hard. I wanted to challenge you guys and see if any of you could solve it. But, I mean, Dinsmore warned me that it would crush all of you. I said, no, you have to let them have a chance, see if they can survive. But I did put it at the end of the test to be nice on test 1, right? But the interesting thing here is actually the theta doesn't matter, because we can use conservation of energy. Like, energy is conserved no matter what theta is, right? And the thing is, conservation of energy says that mgh plus 1/2 mv naught squared is equal to 1/2 mvf squared. And it doesn't care what the direction of the final velocity is, right? The direction of the final velocity, of course, would be different for different theta. But the really cool thing is we can solve this problem with almost no thinking. When you contrast what we can learn about this physical motion on test 2 as opposed to the way we had to think about it on test 1, it's really, really striking how much better energy analysis is as a means of understanding basic physics, right? I hope you see that. I know you're probably sad about points you lost about vectors earlier. I often write vector. That's just me warning you that you're getting things wrong because your concept of vector is wrong. That's when I write vector, what I'm saying is you're thinking about vectors wrong, or you're not thinking about vectors, which would be thinking about vectors wrong. And yet, at the same time, I'm telling you, energy methods don't use vectors. Like, make up your mind. I'm sorry. It's both, all right? Momentum is a vector. We have to think about it as a vector. Energy is a scalar, right? And there's an interplay between these ideas. on your quiz, so any questions about the test? That's it. There were 210 points you could have earned. 200 points were required, so there's like 10 bonus built in. I don't think anybody made 210. Oh yeah, that's my plan. The class average was 130. But there's still one student taking it, and they'll probably raise the average a little bit. So, if I had to guess. But, I will replace this test with your final exam grade if your final exam grade is better. I think those of you who, all right, so the average was 130, but if I could draw you like, was it a histogram or whatever, with the bar plot of the grades, you'd see that there are people with 70s on this test or down around there, and they're dragging the average way down. There's a lot of people with 190s on this test. It's not unheard of. So we've got this kind of bifurcation. You've got people who are not just F, they're like solid F. And then you've got like high B to low A grades, and there's kind of everything in between, but listen, those of you who made a bona fide F on this test, that's not the end of the world. If you do better on the final, if you fix whatever it is that you're not doing, you can still not only survive, but thrive in the course. Like, if you ace the final, I will most likely give you an A, all right, if you've actually done everything. Now, if you haven't done any of the homework and you've done other things to annoy me, I might not give you an A, but I would like to give everyone a good grade. It's not my goal to not give you a good grade. I would like you to earn a good grade is really what I'd like to say. Can you pan? Thanks. So, so the quiz that you just took was homework from the book. Those were numbers 63 and 65 in whatever chapter that is. Chapter, what is it? Every day is a study sheet for the final. That would be a no. Let's see here. So what chapter was that? Rotations, right? Chapter 8. Excellent. So 63, I thought it was 63 and 65. 63, the answer was 1/2 omega. 65, the answer was 1.2 kilogram meter squared by pulling her arms towards the center of her body. So, sound good? All right. So I just want to tell you where those came from. This one, how do you do part A? Yes, the dot product of the force with the displacement gives us the work done. Right? So the dot product here would be 300 minus 330 minus 30. Looks like minus 60 joules. Yeah? Do you guys get minus 60 joules? Or did I do it wrong in my head? Oh, be quiet. Yes, 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 yes. Sorry, guys. What would you guys get for the work done? Nobody? What? You got 270? So we've got 10 newtons times 30 meters plus 3 newtons times minus 11 meters minus 6 newtons times 5 meters. What's that give us? Oh, you know what my error was? I thought that was 30. I was thinking 330 from that, which is totally nonsensical. So, so we're subtracting 63 from 300, which is what? 237 joules. All right, I will. Very good. I agree. And how about part B? We calculate torque by what? Yeah, the cross product, right? So torque was R cross F, which we can use the determinant formula for if we like. So I put I, J, did I do IJK in here? I can't remember. Did I do X hats? Oh, I don't even remember. There's two different notations that are popular. Anyway, so 7, 8, 2. My force was 10, 3, minus 6. I'll go ahead and pull the units out here. And so that's going to give me minus 48, minus 6. 20 plus 42 and minus 48 minus 6. However you do it, it's your business. I'm just doing it my way. And we'll check my answer in just a second here. Minus 54, 62, minus, what is that? 54? Did you guys get that? Or have I made a mistake, which is totally possible? I'm an idiot. This last one's crazy. Sadness. What's that? Negative 59. Now does it look better? And so to check our work, we should take the dot product of this torque vector, alleged torque vector, with the 782 or the 10, 3, minus 6. I'm going to do the 10, 3, minus 6 because I'm lazy. That gives me minus 500. Whoa. So with minus 540, yowzers, 3 times 62 is what? 186? And then minus 6 times, what's 6 times 59? 345? But that's a plus because minus and minus gives me a plus. What we got here? Uh-oh. Uh-oh. Someone care to tell me the error of my ways? You guys just leave me hanging? Fine. Let's see what you guys got. I got a 42. That doesn't look right. Well, You know, sometimes we're told that diversity is a good thing. Diversity in answers, though, nah, it's not good. Not for a math problem. Minus 54, 62, minus 59. This person has my wrong answer. Do I trust this person? Well, same wrong answer again. Different. Same wrong answer again. I'm betting I've checked my answer wrong. So I did this times that is minus 540. 3 times 62 is what? Is that 186? Yep. And what's 6 times 59? Oh, there it is. What is it? Yeah. Does that help? Is this that? Yay, so the dot product is 0. In fact, that is the right answer, which is good, because at least one or two of you had that. So, anyway, we can all calculate cross products and dot products carefully for the final. These are easy points. This is a stupid, mindless math thing you can learn. It's not that bad. You can do this. Next time, I will start on number 3. Thanks, guys. Sorry, today was kind of a...
I have a question. No, I did pretty well, but I was just wondering if I would have had a length for this. I did take it early, so I didn't have the length.
Oh,
If
yes, I meant, yes, I give you back those points.
I just feel
Yeah,
like I
no.
would've got it.
I was trying to keep track of that, and I lost track of you in the shuffle. I'll change that. You have a 2 of 4.
Okay.
Yep.